Hello guys, welcome to my channel. My name is Patrick and you are in Electro&science. This channel is about electronic and DIY projects. The main purpose of this channel is to help you with your DIY project, such as this kind of project using Arduino programmation and many more, as you can see. But let me tell you the truth. Before doing such thing, you need some basis. So the basis is like understand the component, the simple component like a resistor, diode, transistor, and many more. If you are not subscribed, please subscribe to my channel. This one is a new channel, so I want you to help those electricians or those enthusiast electronic, so to join us to create a big community of electronic. So without further ado, let's get started. As being said, today we'll talk about resistor. What is a resistor? A resistor is an electronic component that has the property to reduce the electric current flow. We use them to make many applications such as current divider, voltage divider, and also to protect like some diode and LED, as I'm saying. And today I will introduce you how to use them and how to make some calculation around the resistor. First, we have to identify the resistor. This one is a standard resistor. This one also is a resistor, the high power resistor. This one is a ceramic resistor, and this one is a carbon resistor. This one also is a resistor, but the difference between this one and others is that this one can be adjustable. Let me explain to you. I can use this cursor to define or modify the resistor values, to adjust, increase and decrease the resistor value. That's all. And also we have this one. This one too is a resistor, but this one is a variable resistor. You use this one to detect light or darkness, and to, let's say, compute or make some application. And then if I use this one, I can make it come to modify the resistor value. Let me show you how it works, because like this maybe you don't get me. If I use a multimeter and I go to voltage feature, if I put this one to that place, also this one to that place, we see I got some value. But if I modify, you see the resistor value increase until got that resistor 198.80 kilo ohms. Yeah, that's all. And the same come to this one. As for this one, you can see the resistor value there, but this one you can see. That's why I use a multimeter. We will talk about how the resistor is connected configuration. We have series configuration and parallel configuration. What is the series configuration? The series configuration is used to increase the resistor value. Let me explain to you by using multimeter. This multimeter, this feature there is a ohms. I made a video about how to use a multimeter to measure electronic component, or let's say the physical feature, but voltage, current and many more. You can watch this video. First, let me place this one there and this one also there. You will get a value. This one is the resistor value, one resistor value. But if I put them in series, I will get 200 ohms. That's all. And also I have this configuration. This configuration is used to decrease the resistor value. If I put this one in series, I will get the half, because I have the same resistor. As you may know, this one is 100 ohm, so I have 200 ohm connect in parallel. That will give me 50, because as the resistor is the same and put them in parallel there, so the resistance value will be divided into. Let me give you a more details about this. I want us to be like comfortable after. I will call this one R1 and this one R2. and the amount is RT. Let us calculate RT. You already know that if I want the current, the voltage there is R1 plus R2 plus R2, that gives us a 200. The proof is that one give us before 200. Yeah, and this one I will call this one RT. The law say that RT equal R1 times, this one is 1, times R2 divided by R1 plus R2. So replace, if I remove and put the values, this one 100 times 100 give me 10,000. See, 10,000, and the R1 plus R2 will give me 200. If I cancel these two, I will got 50. It's 100, so over 20, over 2, please, over 2 will give me 50 ohms. And then if I measure it there like this, there and there, that place, I got 50 normal. I got 50. So there are also a law that we have to keep in mind, the Ohm's law. Ohm's law says that the voltage across a resistor is proportional on the proportional of current to the current. See, they say that voltage equal resistor times I, intensity. Keep this one in mind. Voltage equal resistor times I. Now we can go keep it, this one in mind. It's a very important information if we deal with the resistor. I hope you are keeping this. Now let us move on. To that place, I hook up that a DC voltage 5 volt with a resistor. I want to show you the formula that I give you right now. This is a resistor. Let us measure the current. If we want to measure the current, you have to put your multimeter in series. Let me show you that we have a DC amps, so I will have to use this one, put this one in to that place positive, and this one to that place, and I got a 90 milliamps. You see, this one is a low resistor, and let us come to bottom. I will show you a difference. If I come in bottom there and I want to measure the current, I will do the same, just like this, and then I got 41. As this one is high, you see the voltage is the same as 5 volt, but as this one is a high resistor, I got 41 milliamps instead of 90 something before. That's why I want you to understand. You use this thing to protect a LED. If you want to protect this LED, the LED manufacturer give us some information. They give us the light voltage that we can maybe it is a blue, like give me 2.5 volt, and also the current can be like 30 milliamps like this. If you go over 30 milliamps, your LED could blow. See, if you want to keep that voltage, and if you want to reduce the voltage and so the current, we should use a resistor. But which kind of resistor we should use? Now we are going to calculate a resistor, and then to protect this LED. So the formula say that, the book law say that if I have, but you will see it as normal. If I have 5 volt, this one is 5 volt. 5 volt minus the V LED, the one that I showed you before, minus the I LED times R. will give me 0. I know this one is far. The manufacturer give me this one and this one. Now we have to found a resistor. The resistor will be 5 minus V LED all over I. That's all. And we get the resistor. We will get the resistor value. Simple. Now let me use another kind of a measure tools. This one, the amp meter. So this one is also a multimeter, but this one is high power multimeter. Imagine you wake up with a big motor. We can come with this one, the old one, and come and cut. Let me cut for you. So if you use this one if you want to measure the current, you have to cut this wire. Let me cut it and do it for you. If I cut this wire now and simulate again, I have to go to amps, there, take this one as I said before, and put this one into that place, and take this one, this one, as we see the black one, and come to that place. You see there I have 0 because I didn't put it in a normal values there. So let me do it correct. This one should go there, and this one should go to that place. Yes, now as you see I have 36 milliamps. You see all the milliamps, so always you have to cut the circuit. If you don't want to cut the circuit, it's very simple. I will just make the wiring, and if I compute again, I can leave this one and put this one in amps. And so I just pick this one and come to that place to place it. And I got mine 36. Why man? Because I put this one in the black side. I have to put this one is positive. I put it in mine. So if I put it in positive, you get positive 36. This is the current across all of these elements. Yeah, so now let us go to the current divider and voltage divider systems. We call this configuration the voltage divider. We put 2 resistors in series. If you put 2 identical resistors in series and hook up with the voltage, we divide the voltage in 2. The formula says that. Let me give you another formula. The formula says that if I want the voltage there across this resistor R2, and this one I will call this one R1. If I want the V1, this one voltage across R2, I have to do like this. This one like this. VR2 equal to 5 times R2 divided by R1 plus R2. Very simple. If I have this one 100 and 100, if I made or do all, I should get there 2. This one we cancel and we give you 2. So I will got 5 over 2. That will give us 2.4 2.5 like this. And now if I simulate, you will see it very clearly. If I simulate as I did and use my multimeter, if I measure the voltage to that place and to that place, I will got around 5 volts. This one, okay, let's see, I use AC voltage. If I will come to DC, you have to be careful when selecting your multimeter range. I have 4.97, and then if I pick this one to come, and then as you see the voltage divided by 2, we call this one a voltage divider. Also, let me come in back. There we have current divider. Let me explain to you. After it, we will do a simulation to get best understanding. So they say that this is our power source. the voltage, the current there. Yeah, we have a current there that we call I. The current passes through like this. If the reach that place, you divide to go, I will call this one R1 and this one I2. It divides, yeah, come there and go there. So after this one we go there, and this one we come there, and they will meet to enter. That means that if I have, let's say, 100 there, and I will got 50 to that place, because I will got this one minus this one, because it divides into, I will got 50 there and also 50 there, and all will come there 100, because there we have 100 come become 50 to that place, 50 to that place, and come again to be a 500 again. Let me use a simulation to show you. I will use this one. Now let's go to amps. If I take the probe and come to that place, I got 100. You see, 100. If I put this one there, I got 50 milliamps. This one is 100 milliamps, and this one is 100 milliamps, and this one is 50 milliamps. As you see, it divided. So we are done with a resistor. After we talk about those components like diode and let's say diode and transistor, and many more components. If you like this video, don't forget to give me a thumbs up, and also subscribe to my channel, because it's new channel, as you can see, and then we can so become like a community. Thank you for watching the video. As I'm being said, so we will meet doing another video.